Okay, this section is on bonding, and I've found a really helpful way to look at bonding is to kind of create a graph of bond stiffness versus Young's modulus. And you can work from the table that's on page 67 of Ashby. So what I'll do is I'll go ahead and pull up a little pad of paper here for me to work on. And you can see on this chart that it shows you the different types of bonds that you see in between atoms, and the different bond stiffnesses in Young's modulus for those bonds. So what I'm going to do is just real quickly create a graph of bond stiffness versus Young's modulus. Ooh, this is messy. All right. And I'll put the log of the stiffness down here, and I'll put the log of the modulus up here. This pen's a bit funky. Okay, and so let's see, the modulus we can see goes from about 1 to 1,000, so I'll go 1 here, and then every decade, like this. And down here, we see the stiffness goes from around the 0.1 scale to roughly 200. So I'll do the same thing down here. I'll go 0.1, and then every decade is every couple of boxes here, 100, and then this will be 1,000. So in creating a graph, I'll just use, I'll start with the covalent bonds here. So the XY values for 1/4 of this box would be, I guess it'd be 180 by 1,000, and the other corner would be 50, 200. So this just sort of helps me get started here. So let's see, X 180 is about here, and 1,000 is right about here. Oi. And then this point right here, 50 by 200, roughly here. So this box represents the range of stiffness and modulus that you might see in materials that are covalently bonded. And so I would do the same thing for all these different types of bonds. So I've gone ahead and plotted all these different types of bonds on this graph right here. And what you can see is kind of there's a set of bonds grouped together that are high in their modulus elasticity and their bond stiffness, and then there's this set down here that's lower. And this actually kind of delineates the distinction between what are considered physical bonds and chemical bonds. So these chemical bonds up here, these involve the exchange of electrons between the atoms, and these down here, which are physical bonds, do not. And you can see that the physical bonds are very weak bonds, like the van der Waals and the hydrogen bonding, and then these chemical bonds are stronger in this order. The ionic is the least strong, metallic is stronger, than the covalent is the strongest. The interesting thing about covalent bonds, they have a high bond stiffness because the covalent bonds are what's called directional bonds. And what that means is the atoms, when they're bonded together, they really care about the angles that are formed between the two bonds, and that makes them very stiff, and you can see leads to a higher modulus elasticity and a higher bond stiffness.